discussion again is on calculation of doses, which is a continuation, but particularly this is calculation of dose based on weight. So when age is considered in determining dosage of a potent therapeutic agent, it is used generally in conjunction with another factor such as weight. So drug doses based on weight are expressed as a specific quantity of drug per unit of patient weight, such as milligrams of drug per kilogram of body weight, or abbreviated as milligram per kg or mg per kg, or milligrams of drug per pounds of the body weight, or milligram per pounds or mg over lbs. Dosing in this manner makes the quantity of the drug administered specific to the weight of the patient being treated. So you're going to compare which is more accurate between age and weight. It's the weight, right? So here are some methods of those calculations based on age, on weight, sorry. So ratio and proportion, dimensional analysis, and reference formula. So for the reference formula, we can make use of Clark's rule, which is equivalent to equals weight in pounds times adult dose over 50, which is considered the average weight of an adult in pounds. But in our setting, we commonly use this formula for kilogram weight. So more applicable in our setting since we usually identify weight in kilograms. So for our computations or calculation, this is the formula that we are going to use. So patient's dose or child's dose equals patient's weight in kilograms multiplied by drug dose in milligram over 1 kilogram or per kilogram. So let's discuss some examples of patient parameters or calculation of doses based on age. So for the first problem, so the usual initial dose of chlorambucil is 150 micrograms per kilogram of body weight. How many milligrams should be administered to a person weighing 154 pounds? So if the initial dose is 150 micrograms per kilogram, how many chlorambucil are you going to administer to a person who is weighing 150 pounds? So for the given, we have to identify the adult dose. So the adult dose is equivalent to 150 micrograms per kilogram, but the problem is asking in milligrams. That's why we have to convert micrograms to milligram, which is now equivalent to 150 micrograms times a ratio that is equivalent to 1000 micrograms over 1 milligram is now equivalent to 0.15 milligram per kilogram. So 1 milligram is actually equivalent to 1000 micrograms. Next, for the patient's weight. So since the patient's weight is in pounds, we have to convert pounds to kilograms. So how many pounds in 1 kilogram? So there are actually 2.2 pounds per kilogram. So 154 pounds times a ratio that is equivalent to 1 kilogram divided by 2.2 pounds. The answer is 70 kilograms. And then the unknown is the dose of the patient in milligrams. So for the first solution, we can use the reference formula, which is equivalent to patient's dose equals patient's weight in kilogram times drug dose in milligram per kilogram. So let's substitute our given. So the patient's weight is 70 kilograms. The drug dose is equivalent to 0.15 milligram per kilogram. So it will look like this. The answer now is 10.5 milligrams. So 70 times 0.15 milligrams over 1 kilogram is equivalent to 10.5 milligrams. So cancel the unit of kilogram. What's left? It's just the milligram. Next solution, you can also use ratio and proportion. Right? So what is missing here is the amount of drug that you're going to administer to 154 pounds or 70 kilograms. And then the one that has a pair is 0.15 milligram per kilogram. So your solution will look like this. 0.15 milligram over 1 kilogram equals X over 70 kilograms. And then multiply each side or cross multiply each side. will become 0.15 milligram times 70 kilogram and x milligram or the unknown times 1 kilogram. Your formula will become or your solution will become x milligram equals 0.15 milligram times 70 milligram divided by 1 kilogram is equivalent to 10.5 milligrams. So cancel the unit of kilogram. What's left? It's also milligram. So for the next solution, you can use dimensional analysis. Your answer should also be equal to 10.5 milligrams. So the solution for dimensional analysis is like this. So 150 micrograms over 1 kilogram. So since the problem is asking in milligrams, we have to convert micrograms to milligram by multiplying it with a ratio that is equivalent to 1 milligram per 1,000 micrograms. So we will cancel now this particular units. What's left? It's just the milligram per kilogram. So since we're only identifying now the unit of the chlorambucil in milligram, we will multiply it with a ratio that is equivalent to 1 kilogram per 2.2 pounds. So to cancel the kilogram, and then you will multiply it with the original weight of the patient in pounds, which is equivalent now to 154 pounds. The answer is also 10.5 kilograms. So the remaining unit, it's just the milligram. Next problem. So the dose of minoxidil to treat acne vulgaris is given in 1 milligram per kilogram per day for 12 weeks. So tablet strengths available include 45 milligram, 55 milligram, 65 milligram, 80 milligram, 90 milligram, 105 milligram, and 150 milligram of minocycline or minocycline. What strength of the tablet and how many tablets should be prescribed for the entire course for a 100-pound patient? So for this 100-pound patient, what is the specific dose? If the adult dose is equivalent to 1 milligram per kilogram, and which among the available preparation are we going to use? And how many tablets are we going to prescribe to this particular patient? So let's write the given. So the dose is 1 milligram per kilogram, and then the patient's weight is in pounds. So we will convert the weight from pounds to kilograms. So multiplying 100 pounds multiplied by a ratio that is equivalent to 1 kilogram per 2.2 pounds. The answer is 45.45 kilograms. And the unknown is the dose of the tablet or the strength and the number or the total number of the tablets that you're going to dispense. So for the solution, again, we can make use of three possible solutions. The first one is the reference formula wherein patient's dose is equivalent to patient's weight in kilogram times the drug dose, which is in milligram per kilogram. So we will just substitute power given to this particular formula wherein the patient's weight in kilogram is equivalent to 45.45 kilogram and the drug dose or the adult dose is 1 milligram per kilogram. 45.45 kilograms times 1 milligram over 1 kilogram. Cancel the unit of kilogram. What's left? It's just a milligram. The answer now is 45.5 milligrams. So according to the available preparation, the nearest that we will use is actually the 45 milligram. Next solution is the ratio and proportion. So we should also get the same answer. So again, this is between two ratios or pair. The 1 milligram per kilogram is the first pair, and the one that doesn't have a pair is the 45.45 kilograms. So how many milligram of minoxidil should a patient take if his or her weight is 45.45 kilograms? So cross multiply the two. 1 milligram times 45.45 kilogram and x milligram times 1 kilogram. Your solution will become like this. So x milligram equals 1 milligram times 45.45 kilograms divided by 1 kilogram. Cancel the unit of kilogram. What's left? It's just the milligram. So the answer is still 45.5 45 milligrams. And then the next solution will be your dimensional analysis. So the same. So you can also use the original weight of the patient, multiply it with a ratio that is equivalent to 1 kilogram per 2.2 pounds and multiply it with now with the dose that is available, which is 1 milligram per kilogram. Cancel the units of pounds and kilograms. What's left? It's just a milligram. Answer is still 45 milligrams. So that is now for the calculation of those based on age. Weight based on